Before we go on to wrap up the solution with the get roots method, recall that this is part of a formula to satisfy this linear equation. And part of the formula is dividing by 2a. So we really want to make sure a is not positive. So I'm going to put a loop around this part where we get a to make sure that a is a positive number before we go on. I'm going to cut this line on here and put it above the positive is positive a. So in fact, I'll start a off at -1. So a will start off as negative. So we're going to put a while loop here. We're going to say while not positive. I'm going to actually take away that variable. So I'm going to say while a is not positive, we're going to have a be getting them. Okay. Down a little. Get the curly braces. And I'll put if a is 0, then right line out. A must be positive. Re-enter. Okay, so this now says if a is not positive, which it won't be the first time, go ahead and get number. If a is negative again, it's going to keep circulating. Keep running this loop until a is positive. And then b will be filled and c will be filled. And the 0 thing's going to happen down below, but I'll erase it later. So I'm going to comment that out again and run this just to make sure the a is forced to be positive. So let's call this -9. A must be positive. Re-enter. Let's try 0. Interesting that I didn't get the statement again. Okay, well. Okay, so it's giving me data from my checking methods, but let's see. Why did it? Oh. A is less than or equal to. That will give me a statement even when it's 0. Okay, so we're ready to work on this get roots thing. I'm going to uncomment it. I already started the heading root here. And I put the directions inside just to help me make sure I did everything. So we have A, B, and C, and we know that A is positive. So we now need to look at the discriminant. So we want to know if the delta is positive or negative. And actually, it's easiest to do this first. I'm going to first check to see if the delta is negative. So watch this. I can say if is positive, discriminant A, B, C. I'm doing two things in this one if statement. I'm asking it to compute the discriminant, and that answer comes back. So say it's -3. Then -3 goes to is positive. So if this is true, that means that I have a positive discriminant, but I actually want to see if it's negative, because then it's just a print statement. So I'm going to put a not around the is positive and discriminant, and the same amount of 1, 2, 3, 4. That's kind of big, isn't it? Okay, let's not do the negative part, the not part. So discriminant ABC, that ends that one, that ends that one. We need one more. So if this is positive, if delta is greater than or equal to 0, the roots are real, so you can print them. So we're gonna, I'll just write print roots. Roots are real, print them. Else, oh, but that doesn't take into if, we need to see if the discriminant is equal to 0. So if discriminant of A, B, C equals 0, I'm just going to put this out here, so get rid of that little error. So this is true. Also, the roots are real and we can print them. Okay, so down here, else, if we get to this point, then the roots are imaginary because discriminant less than 0. And so we're going to do this out again. And say roots are imaginary. Okay, so we'll go back and we'll calculate the roots. Okay, so this is where we were. We know if it's positive, we're going to print the roots. And if it's equal to 0, we're going to print the roots. And if neither of those are true, then the discriminant is negative, and we're going to say they're imaginary. Now, what I hadn't calculated yet is using b squared minus the square root of 4ac over 2a. I totally forget what that's called, quadratic formula. And so I didn't have the quadratic formula created in here. So while I was off screen, I created 2 return methods. One is called root1, so it takes in float A, float B, float C. And I create a temporary variable because I didn't want to put this whole thing in the return statement. So what this is b squared minus the square root of 4ac. And then that whole thing is divided by 2a. So that gives me the first root. The second root is still b squared, but this time it's plus the square root of 4ac. And then that whole thing is divided by 2a. So those should give me the roots. So when I come back up here, I need to do more than one statement. So I need my curly braces. Whoops, wrong curly brace. And here, I'm going to say the first root is plus root 1. That will call the procedure with A, B, C. And the second root is basically the same thing, but I call root 2 instead. Second root is root 2. And I need to do the exact same thing for when the discriminant comes out to 0. So I need my curly braces to do more than one thing. And I'm going to replace these here. Now I'm going to go back up top and erase some of the print statements I had from the beginning. So why didn't I use is positive? Oh, I did. Oh, I ended up not using that. That's okay. So I'm just going to comment out this section. I don't think I need it, but instead of erasing it, I'm going to comment it out. And my main program basically now gets 3 numbers and it makes sure that A is positive. And then it prints the roots. So let's go ahead and print and see what happens. Enter value A, 1, enter value B, 4, enter value C, 1. And it shows me the 2 roots. You could do the math to see if that works. Let me do something where B is small. So let's go 4, 1, 4. Roots are imaginary, and that makes sense. Let me try 2, 4, 1. I want when b squared minus 4ac is negative, so if I do b for 16, let me do 4 for b, and 1 for a, so, and 4 for c. That should come out to 0 there. Okay, so hopefully this program gave you a good idea of how not only to use return methods, but also to break down the problem and do it in parts and test as you go. Okay, let me know if you need more help.